So here in section 2.2, we want to look at some more graphical methods for describing quantitative data. And the first example here, we're going to look at cough improvement scores for using honey as a cough remedy. So these are subjective improvement scores. This is the data for honey. And DM is for dextromethorphan, so that's a regular cough syrup ingredient, and then the control. And we are going to construct a dot plot of the data. So a dot plot here is just a bar graph here where the height of the dots gives the frequency. So I use some software to construct these dot plots here. So this is the improvement score on the horizontal, and then frequency is on the vertical. So this is for all of the data, so all the data combined. And then these three dot plots here, those are for the individual data. So this is the dot plot for the honey as a cough remedy, for the dextromethorphan, and for the control group. So again, how do I get these? Well, you just take each score here. So 5, I put a dot where there's a 5, and then the next number is a 6, and I put a dot for a 6, and then when I get repeats, I stack the dots. That's how we're making the dot plot. Well, I'm more concerned here about how to interpret these dot plots. So how do I assess this dot plot? Well, we can use this acronym SOSS, C-O-S-S, Center, Outliers, Symmetry, and Spread. So where is the center of the data? So again, these are just estimates here, but the center of this data, I would guess somewhere in here. So this is 5, 6, 7, 8. So I'm just trying to judge about half of the data above and about half of the data below. So maybe 8 to 9. So somewhere in here. So center, 8 to 9 is an estimate there. Outliers, is there any data that's far away from the rest of the data? Any outcasts here? Well, I do see a gap here. So we had some scores of 5, 4, and 3, no scores of 2, and then 3 scores of 1. So with that gap there, these data values here, those 3 ones, those could be possible outliers. So outliers, the 3 ones here, question mark, those could be possible outliers. Is there symmetry in the distribution? That's another thing that we want to assess here. So if we sort of sketch the curve that would go across the top of these dots here, we see that there's really not a lot of symmetry. So this is not symmetric. So symmetry would be the right half of the data is a mere reflection of the left half. So we're not really seeing symmetry there. Not really seeing a lot of skewing going on either, although we will in some of the individual data. And then the spread of this data, it's pretty easy here to tell the lowest values are 1, the highest values are 15, so we can give min to max 1 to 15. And then this data is really quite spread out over the whole range of 1 to 15. It's not super concentrated in one area here. So we could just say that it is quite spread out. Now when we look at the individual data here, we can also assess center, outlier, symmetry, and spread for each subcategory. So for example here, if you ask what's the middle of each one of these distributions, so the middle for the honey here, I would guess that somewhere in here. The middle for the dextromethorphan, I would guess about right here. And then the middle for the control group, I would guess about right here. So just estimates of the middle, and I'm trying to estimate like same amount of dots above and below the arrow there. So what we see is that the average or the middle for honey is greater than dextromethorphan is greater than control. So for our center here, for center, what we are seeing is that control is less than dextromethorphan is less than honey. So we're seeing general patterns in where the middle of the data is. Outliers. So in just the honey data here, we do see 2 gaps. So we've got quite a large group here that's away from the rest of the data with those couple of gaps in there. So these could be possible outliers here. So for our outliers here, I'll circle those in red. So these could be possible outliers. In the dextromethorphan group, we've got a gap there. These could be possible outliers. And then in the control group, looks like we could have some outliers here and maybe up here also because we've got gaps in the data. And this one possibly could be an outlier. Now later we'll have strict criteria for considering outliers. For right now, just possible. It's possible that those could be outliers. So looking for gaps in the data. Symmetry. So if we draw what the curve looks like for the honey curve here, that is looking like that is skewed. So this one looks skewed to the left. It's skewed whichever way the long tail goes. And then this middle one, well, it almost looks like it's got some symmetry there. It's got a little bit of a longer tail going off to the left, but that one's somewhat symmetric. And then this last one, this actually is symmetric, fairly symmetric here, but it's got some areas of concentration on the end. So this one is symmetric, pretty symmetric anyways. This one here, you could probably argue that, it's fairly symmetric and, maybe a little bit of skewing to the left here. So we could maybe say, somewhat symmetric. More qualitative language there. And then the spread, so if we look at, min to max here, it looks like the honey data is probably the most spread out. It's spread wider than the dextromethorphan and probably a little bit wider than the control group. So it looks like here, the honey data is more spread out. So those are the kind of assessments that you can do with a dot plot. Now, another way to display the data is in what's called a stem and leaf display. So in a stem and leaf display, it's sort of like a horizontal bar graph here where the stem is the digit left of the decimal and the leaf is the digit to the right of the decimal. Or sometimes the stem will be the tens digit and the leaf will be the ones digit. So, and then that's actually what we did here. My stem was tens digit, the leaf was the ones digit, and so we've got, this is the zeros row and then the tens row. So these are all the single digit numbers. So 0, 1 is saying that there were 3 ones, 3 threes, 3 fours, 4 fives, and so on. And then these 4 zeros correspond to 4 tens, 1 0, 1 0, 1 0, 1 0, and then these 6 ones correspond to 6 11s here. And so that's our stem and leaf plot. It's not really giving us a lot of information because there's only 2 classes here. So there's really too few stems too few stems, which determine the classes, to really analyze with our acronym SAUCE. So if we had more stems, so if we had data that was in the single digits, the 10s, 20s, 30s, 40s, 50s, and 60s, then a stem and leaf plot would probably be a better option. Notice that these are in increasing order. All of your leaves are in increasing order, so that means that you can recover the original data from the stem and leaf plot.